Welcome to the Unox Valve channel. In this video, we'll talk about how a solenoid valve works and where it is used. Solenoid valves are used in many industries and have a wide variety of applications. In this video, we'll cover three types of solenoid valves: direct-acting, pilot-operated, and semi-direct acting. Let's begin with the direct-acting solenoid valve. When the coil is energized, it becomes magnetized, allowing the core to move up and down. This movement changes the valve's position, either open or closed. The main components of a direct-acting solenoid valve are coil, hive, spring, core, orifice, and valve body. In a normally closed valve, the spring pushes the core down, keeping the orifice closed. When the coil is powered, it generates a magnetic field that pulls the core upward, overcoming the spring force, opening the valve. When power is cut, the coil demagnetizes, and the spring pushes the core back down, closing the valve again. Here you can see the valve in both its energized and de-energized states. Now let's take a look at the pilot-operated solenoid valve. Its components include coil, hive, spring, core, valve body, orifice, and diaphragm. In a normally closed pilot-operated valve, there are two pressure zones. A small hole above the diaphragm allows pressure to equalize between the top and bottom. This lets the fluid fill the upper chamber of the diaphragm. As pressure builds above, it pushes the diaphragm downward, keeping the orifice closed and preventing flow. The core controls the pilot orifice, which regulates this upper pressure. When the coil is energized, the core is lifted, and pressure from above the diaphragm is released through the outlet. This causes the diaphragm to rise, opening the valve and allowing flow from inlet to outlet. When the power is turned off, the core drops back down, closing the pilot orifice. Pressure again builds above the diaphragm, pushing it down, and the valve closes. If the valve is normally open, it operates in the reverse way. Pilot-operated solenoid valves are ideal for high-flow applications. They require a minimum 0.5 bar pressure difference between the inlet and the outlet to function properly. Finally, let's look at the semi-direct-acting solenoid valve. In this design, the core and diaphragm are mechanically connected. There are again two pressure zones: the inlet and the area above the diaphragm. A pilot hole on top of the diaphragm allows pressure to build up above it, pushing it down to keep the valve closed. When the coil is energized, a magnetic field pulls the core upward. Since it's connected to the diaphragm is also lifted, fully opening the flow path. The pressure difference also assists in opening the valve. When the power is off, the core is pushed back down by the spring, closing the pilot hole. Pressure builds again above the diaphragm, pushing it down, and the valve closes. Semi-direct-acting solenoid valves can operate even at 0 bar pressure differential, while still offering high flow capacity. Unox Valve. Direct your fluid.